38. Here's the notes for 10.1 is use properties of tangents. It's 39 and 40. Okay, I'm going to put the PowerPoint online that you can print off if you like, and just glue them into your book if you like, but title it Use the Properties of Tangents. This is on page 39. Theorem 10.1 is the plane of a line of tangent to a circle if and only if the line is, you notice right there, means that it is perpendicular to the radius of the circle at its endpoint on the circles. So right there at point P, where this line here is called the tangent, meets the radius OP here at a 90-degree angle. That's what's making it the point, and that particular point is the point of tangency that was referred to on your notes. I mean your vocabulary. Point of tangency is that point where it crosses or it touches at a 90-degree angle. And then on Theorem 10.2 says a tangent of segments from a common vertex. So here it has common vertex of S is the external point of these two things. If you notice right there on your picture, it has those markings, which means they're going to be congruent. And these are two tangent points because they meet outside the circle at exactly one point, which is T and R. So those particular items are perpendicular. Okay, since I'm gluing these in, I had to put it on the back of this page, which you can do the same for examples. This first example, it says tell whether the line, ray, or segment is best described as either a radius of the circle, a chord, diameter, secant, or tangent of this circle. And that's the symbol for a circle P, being P is the center of the circle. And if I look at the first one, notice this has RT with just a line over the top of it. RT right here, notice it goes from one side of the circle to the other and it goes through the center. That means this is called the diameter. Okay. Alright, I zoomed in a little bit because so you can see that WT, there is an arrow right there symbolizing that this is a ray. If I look at WT, right here is going in this direction all the way through over to this side. Notice it touches the circle at exactly one point, which is point T. That means this is a tangent, and T is actually the point of tangency. If I look at C, it has PT. PT goes from the center to the side of the circle, which is called the radius. And then RQ, R and Q touch the circle, but notice it's going all the way through in that fashion, and they have arrows on the ends. Notice here it has arrows when it goes through the circle at 2 points. That is called the secant. Notice if this did not have arrows on the ends, you may have to zoom in or look at the PowerPoint to see that those are arrows there. If it just was a segment, then this would be called a chord. Okay, example 2 gives us many circles here. It says find the length of the circle in the coordinate plane. On A, it wants to know the diameter of circle P. Well, if I go to circle P, the diameter means I'm going from all the way from top to bottom, or I'm going all the way horizontally across. It does not matter, but notice this is counting by 4s, so this means it goes twice, which means this is 8 units. Okay, circle Q. If I look at the large circle here, I can either go horizontally or vertically, whichever we prefer, but notice this moves 2 units, and 2 units would be 8, so go all the way across. I'd have to double that, and that means this is actually 16 units. Now on C, it wants to know the radius of P. Well, the radius of P will be half the diameter, or I can just look at it and see that this is 4 units. And then on D, it wants to know the radius of Q. Well, Q is half of 16, or I can count and see that it is 8 units. Okay, I'm going to page 40 now. It says verify a tangent to a circle. It does say that AB right here is a radius of my circle A, and it wants me to show that BC is tangent to circle A. Well, to be tangent means I need to prove that this is a right angle. And if you notice, here is a right triangle that I have that appears here. So that means I'm going to use the A squared plus B squared will equal C squared to test to see if it is actually a right triangle. So if I start out, I'm going to have A squared plus B squared equals C squared. A will be 8 squared plus B, which is 6 squared, should equal 10 squared. 8 squared is 64, 6 squared is 36. Together that gives me 100, which 10 squared is 100, and this matches. Therefore BC is tangent to circle A. On example 5, it says QR is tangent to circle C at R. There's my point of tangency right there. And QS is tangent at point S. That means if I bring that straight down in those fashions, I have right triangles here. If I was to draw a line that goes all the way through, there is my right triangle that I could actually have. Now, it says we want to find the value of x. Well, if I know that these two guys are tangent, that means that both of these are congruent to each other, and I can solve this by setting them equal to each other. So I'm going to put 3x plus 5 equal to 32, and I want to solve this algebraically. Well, in solving it, I have to get rid of the 5. If I subtract 5, that gives me 3x is equal to, what is that, 28? No. 27, I believe. And then I'm going to divide by 3. That gives me x is equal to 9. Remember, I can plug this back in and see that 27 plus 5 is 32 for my problem to make sure that these two guys are equal. Okay, here's your practice problem number 1. You want to work that problem and then restart it. Okay, here is practice problem number 2. Practice number 4. And practice number 5. I did drop number 3 because it was not necessary. Alright, on number 1, it says tell whether AB is best described as a radius, chord, diameter, secant, or a tangent, and then explain. AB, A and B are on the outside of the circle, and that line goes through the center. That makes this a diameter. It goes through the center. I don't have my white out. Oh, there I do. It goes through the center. Okay. On number 2, it says use the diagram of the radius of a circle and the diameter of D. We want to find those particular items. So if I look at circle C, the radius C, I'm going to go straight across. Notice this is count by 1, so that means it's 1, 2, 3 units for the radius of C. And then of circle D, it wants to know the diameter. The diameter goes all the way across, which means it is 2 units. Example 4 says that RS is a radius right here of that circle R and is tangent to circle R. Oh, I forgot to put in there is ST. I forgot to insert that in there. Is ST tangent to circle R? Well, to know if it is, I need to check to see if this is a right angle, which means this is Pythagorean theorem again. But realize 8 is from the outside of the circle to T. Right here in this section, this is still a radius, so that means this is still equal to 5. So this entire distance is 13. So I need to check this with Pythagorean theorem. I can see that here's A, this side is B, and this side is C. So for my Pythagorean theorem, I can do 5 squared plus 12 squared, and it must equal 13 squared. That's 25 plus 144, which this gives you 169, which 13 squared is 169. So this is tangent, and also realize this is a triple. On number 5, it says RS is a tangent to the circle at point S. RT is tangent at point T. Find those values, which means these two guys are equal. So that means I'm going to put x squared equal to 49. And the only way to get rid of a square is to take the square root, and that means x is 7. Or realize x could also be negative 7. So there's actually two answers on this, because when I plug 7 or negative 7 in for RT and I square it, I will get 49. That's why there's an S right there. There is a possibility of two answers. Alright, I'll see you in class.